Today we're going to be talking about something a little bit different from our usual. In this case, we're talking about a titration lab. This is a very, very common lab that you'll do quite often when you get to a chemistry lab. I wish we could have done it this year in person, but unfortunately that's not the case. So I'm going to tell you a little bit about it, and then you'll watch a video that'll walk you through step by step what a titration lab looks like and sort of the purposes of why we do them. So this definition taken from your book to explain titration tells us that the controlled addition and measurement of the amount of solution of a known concentration required to react completely with a measured amount of a solution of unknown concentration. So what does that mean? That is a lot of words. On the right, I have a picture of a titration lab setup. Notice you have your stand, you have your burette clamp, and then you have your burette on the right-hand side that is attached to that clamp. At the top, you would take your initial reading of whatever that known solution is, and then at the very end of the titration, you would take your final reading wherever that may be. For titrations, you're either adding an acid to a base or a base to an acid. So depending on which way you have it set up, your known, whatever that known value is, what will go in the burette. That is called your titrant. This is the thing that has a known concentration that was given to you. Inside this Erlenmeyer flask, you will put what's called your analyte. You may also see it called titrand with a D at the end. And this is your unknown solution. So you may have a base, but you don't know the molarity of it. Or maybe you have an acid, but you don't know the molarity of it. So whatever that may be, you are adding that a known amount to your Erlenmeyer flask. Again, you have to know the volume before you add it in, because the only way to calculate the molarity is if you know that volume, and you can find the moles through this lab. You'll also add in an indicator. It tells you right here that it's this little pink little splotch you see in the Erlenmeyer flask. Indicators can be a wide variety of colors, and how you choose that indicator really depends on what you're trying to measure. So on the left-hand side, I have a diagram of so many different indicators that you'll see quite often in the lab. And it tells you sort of based on the pH where it changes colors and what that color changes to. So notice, for example, a common one you'll use in the lab is this phenolphthalein. It changes colors, maybe right around 8, it's still white, and then by the time it gets to 10, it's very pink. So on that pH scale, around a pH of 9 is when that color changes from white to pink. So that's probably the one they were showing you in that picture right there. That was probably phenolphthalein. So how do you decide which indicator to use? Well, it depends on where your equivalence point is. So the equivalence point is whatever the stoichiometric point is in a titration, where the moles of your titrant, that thing that you know the concentration of, equals the moles of your analyte, or that titrand, the thing that is unknown. So basically, this is the point when your moles of your acid is equal to the moles of the base. So if that equivalence point happens around this pH of about 7, then you'll want to use an indicator that will change colors around a pH of 7, so that you can visibly see that color change and know that your reaction has taken place. So the end point, that's just the point in a titration when your indicator changes colors. Basically, that end point, when that changes colors, it indicates that you have reached your equivalence point. So again, you're adding a titrant, something that is known, to an analyte or a titrand, something with an unknown value. So either adding an acid to a base or adding a base to an acid. And the goal for your titration is to be able to determine the concentration of whatever that unknown substance was. So again, you're going to be watching a video where someone will walk you through every single step of a titration lab, how to solve those equations, and then you're going to do just a few of your own to determine what you think those unknown concentrations are.